Lesson 4 on absolute value is on absolute value transformations. So if you recall the definition of an absolute value, we can look at it as in two pieces. The absolute value of x is equal to just x when the value of x is greater than 0. And it's equal to negative x when the value of x is less than 0. Because what I would have in that case is I'd have negative of a negative 2, which would equal a positive 2. And the absolute value of negative 2 would be equal to positive 2. So that's
Mrs. Hampton, line 1, please. Mrs. Hampton, line 1.
That's where this piecewise comes in. So an absolute value transformation transforms the graph of a y equals f of x to the graph of y equals the absolute value of f of x. So if we investigate, a function has an equation of y equals x minus 1. So if we were to write this equation as being the absolute value of f of x, it would be y equals the absolute value of x minus 1. Okay? So it says complete the table of values for f of x, y equals f of x and y equals the absolute value of f of x. So if you want to press pause, you can then watch or do the table of values, and then you can turn it back on to see whether or not your table of values match up. So when x equals negative 4, I get negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. When it's the absolute value, these negative values, the absolute value of them would be a positive value. So there would be my two equations. And then we're asked to graph them both on the same grid. So again, graph and then compare what you have to what I have. X equals 1, 0. So this is my y equals f of x. And my absolute value equation, these right here would be 0, x equals 4, 5. And so then my graph in blue is my y equals the absolute value of f of x. So it says complete the following statements based on the observations of these two graphs. So when f of x is greater than 0 or equal to 0, that's this part. So when this part of the graph, that's what's in green, so that was this part here, is greater than 0, the graph of the absolute value of f of x is the same or identical to the original. In other words, these two parts are the same for all the values that are greater than, or when f of x is greater than or equal to 0. When f of x is less than 0, so f of x is less than 0, that's these values here. What is the relationship between these two graphs? So what is, if I had to draw from this graph to this graph, what would I do? I could reflect this in the x-axis. So it is a reflection in the x-axis of the graph y equals f of x. Okay, so let's look at the next equation. f of x has an equation y equals x squared minus 4. So if I was to write the absolute value equation, it would be y equals the absolute value of x squared minus 4. And it says use a graphing calculator to sketch the absolute value of f of x. So if we grab our calculator, I have y equals, my first equation I would put in would be my x squared minus 4. And then if I look at these window settings, these go from 5s. So negative 5 to 5, negative 5 to 5. So if I graph, there's my first equation. That's the equation that's already drawn for me. Then if I look at my absolute value of x squared minus 4, I press math, go over to number, and it's selection number 1, and I get ABS bracket, or it might put in the lines for me, and then x squared minus 4. And when I graph this one, I get that funky looking shape again. So what that looks like is this part of the graph here stays the same for both graphs, and the part in the center goes like this. So do the observations from here do the same in this example? In other words, when the original function is greater than 0, does it match the absolute value? Yes, it does. When it is less than 0, is this part here a reflection in the x-axis? And the answer would be yes. So in general, given the function y equals f of x and the graph of y equals the absolute value of f of x, they have the following characteristics. When f of x is greater than 0, in other words, when the graph of f of x is above the x-axis, the absolute value would be identical. When it is below the x-axis, the absolute value function would be a reflection in the x-axis. So if we look at question number 3, and we are asked to sketch the absolute value of these functions, we can use that understanding. We don't need to know what the equation is. What we need to know is everything above the x-axis stays the same. So in my absolute value function, this would stay the same. The part that's below the x-axis would reflect up. So this portion of the graph would reflect up and over. So that this looks like a reflection and this is the identical. So if I look at B, there is nothing above the x-axis, so nothing would stay the same. All of this would reflect up. So if it reflects up, it's going to have a look something like that. So the last question says, consider all the graphs that we've done in parts 1 to 3 of the investigation. Compare the following aspects of the f of x function to the absolute value of f of x. Domain. What can you tell me about the domain of the original function and the domain of the new function? The domain of the original and the domain of the new. Domain being my x values. Do they change or do they stay the same? They would stay the same. Okay, so now think of the range. The range are my y values. What change do I see in the range from the original function to the absolute value function? Well, the change in the range only occurs for the values that are less than 0. So the way that we can write that is we can say when f of x is greater than or equal to 0, the range is equal to the absolute value. Y equals the absolute value of f of x. When f of x is less than 0, So when the values are above the x-axis, the range is going to be the same. When it's below the x-axis, it will be the reflection or the negative value of that portion. So if I look at this, my range for this part is going to be the same as in the original equation. And in this part here, the range is the negative of this part. So imagine that this might be like -1. Then that means that the new range would be a +1. X-intercepts. Where does it cross the x-axis? So if I look at my graphs, x-axis, x-intercept, x-intercept. If I go back to the previous page, x-intercept, x-intercept. X-intercept, x-intercept. So the x-intercepts would be the same. So this would stay the same. Now take a look at the y-intercepts. What can you tell me about the y-intercepts? Well, if the y-intercept of f of x is greater than or equal to 0, so if the y-intercept is positive, then it stays the same. If the y-intercept of f of x, y-intercept of f of x is less than 0, then the y-intercept of the absolute value of f of x would be equal to the opposite value, which would be the positive value. So if the y-intercept is -4 in the absolute value equation, it would be +4. So the questions that I want you to work on are questions 1, 3, 4, 6, and 7.